Hi to everyone, myself Dr. Dhananjay Rao, working as Assistant Professor in the Department of Chemistry. Today I am going to teach about the properties of lubricants. In this session, I am going to cover lubricants and properties of lubricants like viscosity, flash and fire point, and cloud point and pour point. In this session, I am going to cover lubricants and the properties of lubricants like viscosity, flash and fire point, cloud and pour point. See, before going to this, we should know about the lubricant. Lubricant is a substance used in between two moving surfaces to reduce the friction. What is lubricant? Lubricant is a substance used in between two moving substances. Two moving surfaces are two moving substances to reduce the friction. To reduce the friction, you have to apply lubricant between two moving surfaces. It's called lubricant. Lubricant is a substance used in between two moving surfaces to reduce the friction. What is meant by lubrication? Lubrication is a process of reducing friction and wear between two moving surfaces. What is lubrication? Lubrication is a process of reducing friction and wear between two moving surfaces by adding lubricant in between them. Okay, lubricant adding in between the two moving surfaces. What is meant by lubrication? Lubrication is a process of reducing friction and wear and tear between two moving surfaces by adding lubricant in between the moving surfaces. See the functions of a lubricant. Lubricant prevents the direct contact between the moving surfaces. The lubricant prevents the direct contact between the two moving surfaces and it reduces wear and tear. Between the two moving surfaces and surface deformation of the concerned parts. Okay, it prevents the direct contact between the two moving surfaces and it reduces the wear and tear between the two moving surfaces and it prevents the surface deformation of the concerned parts. The functions of lubricant is it prevents the direct contact between two moving surfaces and it will reduce the wear and tear between the two moving surfaces and it prevents the surface deformation of the concerned parts. It reduces wastage of energy. Lubricant reduces wastage of energy so that efficiency of the machine enhanced. So the next function of the lubricant is it reduces the wastage of energy. Lubricant reduces the wastage of energy so that efficiency of the machine enhanced. It reduces the frictional heat. The lubricant reduces the frictional heat and prevents the expansion of metals. Okay, other function of the lubricant is it reduces the frictional heat. And it prevents the expansion of metals. It acts as a coolant. Okay, The lubricant acts as a coolant by removing the frictional heat. And generated due to the rubbing of surfaces. It acts as a coolant by removing the frictional heat that is generated due to the rubbing of surfaces. And the lubricant minimizes the corrosion. These are the functions of the lubricant. See, what are the functions of lubricant? It prevents the direct contact between the two moving surfaces and it reduces the wear and tear between the two moving surfaces and it prevents the surface deformation of the concerned parts and it reduces the wastage of energy. The lubricant reduces the wastage of energy so that efficiency of the machine will increase. It reduces the wastage of energy and so that the efficiency of the machine enhanced. It reduces the frictional heat. And it prevents the expansion of metals. The lubricant prevents the expansion of metal by reducing the frictional heat. It acts as a coolant by removing the frictional heat generated due to the rubbing of surfaces. It acts as a coolant by removing the frictional heat generated due to the rubbing of surfaces. And it also minimizes the corrosion. These are the functions of a lubricant. What is lubricant? Lubricant is a substance that is used in between the two moving surfaces to reduce the friction. To reduce the friction, the lubricant is a substance that is used between the two moving surfaces. What is meant by lubrication? Lubrication is a process of reducing friction and wear and tear between two moving surfaces by adding the lubricant in between the two moving surfaces is called lubrication. What are the functions of a lubricant? It prevents the direct contact between the two moving surfaces and reduce the wear and tear, and it prevents the surface deformation of the concerned parts, and it reduces the wastage of energy so that efficiency of the machine will be increased. It reduces the frictional heat and prevents the expansion of metals. It acts as a coolant by removing the frictional heat generated due to the rubbing of surfaces, and it also minimizes the corrosion. These are the functions of a lubricant. See the properties of a lubricant. The properties of a lubricant. In that we are going to learn about viscosity. It is a property of the lubricant. See the viscosity. Viscosity is a measure of the internal resistance of a liquid. The viscosity is a measure of the internal resistance of a liquid during its flow. What is viscosity? Viscosity is a measure of the internal resistance of the liquid during its flow. Is called viscosity. Viscosity is a measure of the internal resistance of a liquid during its flow. It is expressed in centipoise. The unit of the lubricant, the unit of the viscosity is the centipoise. It is expressed. The viscosity is expressed in terms of centipoise. This is the unit of the viscosity. The viscosity of an oil is the time in seconds for a given quantity of oil to pass through the standard orifice under the specified conditions. The viscosity of an oil is the time in seconds for a given quantity of oil to pass through a standard orifice under a specified condition. How we can measure the viscosity? See, the viscosity can be measured by the time in seconds for a given quantity of oil. The time required for a given quantity of oil to pass through a standard orifice, under the specified condition. By this method, we can measure the viscosity of the liquid. See the significance of the viscosity. See, if the viscosity of the lubricant oil is too high, the viscosity of the lubricant oil is too high, the movement of the machine is restricted due to the excessive friction. What happens if the viscosity is more? Okay, if the oil content viscosity is more, then if the viscosity of the lubricating oil is too high, if the viscosity of the lubricating oil is too high, then the movement of the machine is restricted. The movement of the machine is restricted due to the excessive friction. See, if the oil containing more viscosity, then what happens? See, the movement of the machine is restricted. The movement of the machine is restricted due to the excessive friction. If the viscosity of the lubricating oil is too low, then what happens? The liquid oil film cannot be maintained and excessive wear and tear will take place. What happens? The significance of the viscosity is, if the viscosity of the lubricating oil is too high, what happened? The movement of the machine is restricted. Due to the excessive friction. If the viscosity of the lubricating oil is too low, what happened? The liquid oil film cannot be maintained. And excessive wear and tear will take place in case of viscosity is too low. A good lubricating oil should have moderate viscosity. It should contain moderate viscosity. It should not contain too high and too low. A good lubricating should have moderate viscosity. See, the property of the lubricant is, in that first one we are learning about viscosity. What is meant by viscosity? Viscosity is a measure of the internal resistance of a liquid during its flow. We can measure the internal resistance, that is called viscosity. It is expressed in terms of centipoise. The units for the viscosity is centipoise. The viscosity of an oil is the time in seconds for a given quantity of oil to pass through the standard orifice under a specified condition. By this method, we can measure the viscosity. See, the next one is significance of the viscosity. The significance of viscosity. If the viscosity of the lubricating oil is too high, if the viscosity of the lubricating oil is too high, then the movement of the machine is restricted. The movement of the machine is restricted due to excessive friction. Due to excessive friction. If the viscosity of the lubricating oil is too low, if the viscosity of the lubricating oil is too low, then the liquid oil film cannot be maintained. The liquid oil film cannot be maintained, and excessive wear and tear takes place. Excessive wear and tear takes place. A good lubricating should have moderate viscosity. The good lubricant oil should have moderate viscosity. It should not contain too high. It should not contain low viscosity. It should contain moderate viscosity. See, 4 types of lubricating oils are there. See, this is the water. It contains viscosity is too low. Then milk. Compared with the water, the milk viscosity is more. Similarly, if take oil and egg yolk contain more viscosity than oil, and then milk, then water. This is the order. The order of the viscosity is for egg is more, then oil, then milk. Okay. The water contain low viscosity and the egg yolk contain higher viscosity. Similarly, if you take water and oil, which contain more viscosity, the oil is more viscous compared with the water. Okay. The second property of the lubricant is viscosity index. The second property of the lubricant is viscosity index. See, the viscosity of oil decreases with increasing temperature. What happens if the viscosity, if you heat the lubricant oil, what happens? The viscosity of oil decreases with increasing temperature. With increasing temperature, the viscosity of the oil decreases. If the viscosity of the oil decreases rapidly with the increasing temperature, it has low viscosity index. What is meant by viscosity index? It is a relationship between temperature and viscosity. Is called viscosity index. What is meant by viscosity index? It is a relationship between temperature and viscosity. Is called viscosity index. The viscosity of oil decreases with increasing temperature. With increasing temperature, the viscosity of oil will be decreased. If the viscosity of oil decreases rapidly with the increasing temperature, it has low viscosity index. Okay. If the oil contain low viscosity index, what happens? The viscosity of oil decreases rapidly. The viscosity of the oil decreases rapidly with increasing temperature. With increasing temperature, the viscosity of oil decreases rapidly. Then the oil contain low viscosity index. That oil contain low viscosity index when the viscosity of oil decreases rapidly with the increasing temperature. If the viscosity of an oil is slightly affected with the increasing temperature, then it has higher viscosity index. If the viscosity of oil is slightly affected, okay, if the viscosity of the oil slightly affected with the increasing temperature, then the oil contain higher viscosity index. Okay, when the oil contain lower viscosity index, what happens? The viscosity of oil decreases rapidly with increasing temperature. Then the oil contain low viscosity index. When the lubricating oil contain the higher viscosity index, what happened? The viscosity of oil slightly affected by the increasing temperature. Okay, that is called higher viscosity index. For every 1 degree centigrade rise in temperature, the viscosity index decreases by 2%. For every 1 degree centigrade rise in temperature, the viscosity index decreases by 2%. Okay. A good lubricating should have a high viscosity index. A good lubricating oil should contain high viscosity index. Okay, it should not contain low viscosity index and it should not contain high viscosity index. A good lubricating oil contain high viscosity index. It should not contain moderate or low viscosity index. It should contain high viscosity index. The next is the third property of the lubricating oil is the flash point. What is that one? Flash point. It is the lowest temperature. What is meant by flash point? It is the lowest temperature at which the oil gives up enough vapor that ignite for a moment. that ignite a light for a moment. It is the lowest temperature at which oil gives off enough vapor that ignite for a moment when a small flame is brought near it. But it is the lowest temperature at which the oil gives off enough vapor that ignite for a moment when a small flame is brought near it. It is called flash point. What is meant by fire point? It is the lowest temperature at which the vapor of the oil burns continuously for at least 5 seconds when a small flame is brought near it. What happens? It is the lowest temperature at which the vapor of the oil burns continuously for at least 5 seconds when a flame is brought near to it. Okay, that is called fire point. What is flash point? It is the lowest temperature at which the oil gives off enough vapor that ignite for a moment when a small flame is brought to near it. What is fire point? It is the lowest temperature at which the vapor of the oil burns continuously for at least 5 seconds when a small flame is brought to near it. Generally, the fire point is 5 to 40 degrees centigrade higher than the flash point. First, we can observe the flash point, then only we can get the fire point. Okay, then we can observe the fire point. First, we can observe flash point, then we can observe the fire point. See, generally the fire point is 5 to 40 degrees centigrade higher than the flash point. Okay, the fire point is more than flash point. That is 5 to 40 degrees centigrade more than that of the flash point. Okay, we will get the fire point at 5 to 40 degrees centigrade higher than that of flash point. Okay, we will get the fire point. See the significance of flash and fire points. A knowledge of flash and fire points is useful in providing protection against the fire hazard during transport and storage. Okay, the knowledge of a flash and fire point, at point we will get the flash point, at temperature we will get the flash point, and at what temperature we will get the fire point. Based on that knowledge, the knowledge of a flash and fire point is useful in providing protection against fire hazards during transport and storage. Okay, during transport and storage, we should have knowledge about the flash and fire point. At what temperature flash point it is contained, at what temperature it contains fire point. Based on we can transport and storage those lubricating oils. Lubricating oils of paraffin base possess higher flash points than those of naphthalenic base. The lubricating oils of paraffin bases, the lubricating oils made up of paraffin bases that possess higher flash points than those of naphthalene bases. The paraffin bases contain higher flash points compared with the naphthalene basic lubricating oils. Hence, the determination of the flash and fire points, it is helpful in identifying the type of lubricating oil. Okay, by the determination of the flash and fire points, we can variate the naphthalene bases, the paraffinic bases lubricating oils and naphthalenic bases lubricating oil based on the calculation of the flash and fire points. A good lubricating oil should have flash and fire points higher than the operating temperature of the machine. A good lubricating oil should have flash and fire points higher flash and fire point compared with the operating temperature of the machine. A good lubricating oil should have higher flash and fire points than the operating temperature of the machine. See the next step, determination of flash and fire points. Determination of flash and fire points. See description. The apparatus consists of a brass cup in the measurement of flash point and fire point. Okay, that is the apparatus. We can use that Penske Martin. This is the instrument we can use for the to measure the flash and fire point. Okay, this Penske Martin apparatus consists of a brass cup. In that, one brass cup will be there. Okay, it contains one brass cup. This cup should be dried and no moisture should be allowed to remain inside it. This brass cup should be dried. This brass cup should be dried and no moisture should be allowed. No moisture should be allowed to remain inside it. The level up to which oil is to be filled in cup is marked at about 1 centimeter below the top of the cup. Okay, na? Below 1 centimeter top of the cup. Okay, we should fill with the oil. We should fill with the lubricating oil up to the mark. See, the level up to which oil is to be filled in the cup is marked at about 1 centimeter below the top of the cup. From the top of the cup, 1 centimeter below, one mark is there. You have to fill the lubricating oil up to that mark. Okay. First, it's this Penske Martin. By using Penske Martin, we can measure the flash and fire point of the lubricating oils. Okay. This apparatus consists of a brass cup. In this apparatus, Penske Martin contain one brass cup. This cup should be dried and no moisture should be allowed to remain inside it. And the level up to which oil is to be filled in the cup is marked at about 1 centimeter below the top of the cup. The third point is the lid of the cup is provided with 4 openings. Okay, the lid of this cup contain 4 openings of standard sizes, which are meant for special type of stirrer. It contains one special type of stirrer and a standard thermometer. One open for the stirrer. Okay, one opening for the stirring. The second opening for the thermometer. We have to insert thermometer in that. And third inlet for the air. And fourth inlet for the introducing flame. It consists 4 openings. Okay, 4 inlets. This apparatus consists 4 inlets. The first inlet for the stirring, and the second inlet for the to insert thermometer, the third inlet for air, and the fourth inlet for the introducing the flame. Okay, these contain 4 inlets. The fourth point is at the top of the cup a shutter is provided. At the top of this cup, okay, at the top of the cup it contain shutter provided. It will contain one shutter. It close and it will open. Shutter is provided to this cup of the top of the cup. By moving the shutter openings for the test flame and air are opened and the flame exposure device dips into the opening over the surface of the oil. At the top of the cup, a shutter is provided. By moving this shutter, okay, rotating this shutter or opening of the shutter for the test flame, okay, you have to bring the test flame to that shutter and openings for the test flame and air are opened and the flame exposure device dips into the openings over the surface of the oil. The fifth point is the whole assembly is kept in a electrical heater which can be heated in a controlled manner. The whole assembly is kept in a electrical heater which can be heated in a controlled manner. The total setup, this brass cup setup we have to keep in the electrical heater which can be heated controlled manner. Controlled manner means with some constant temperature it will rise. Okay. See, this is the setup of flash and fire point instrumentation. That is Penske Martin instrument. By using this instrument, we can measure the flash and fire. Okay. See, this is shutter control. And this is eye level pointer. Up to this one, you have to fill. Okay, eye level pointer. This is stirrer. By rotating this one, we can stir the oil inside the cup. By using stirrer, we can to get uniform heating of oil, we have to stir this lubricating oil. This is oil cup. This is the heater, electrical heater. By using this electrical heater, you have to provide heat. This is air bath. Okay, this is air bath. Inside there is a air. This is the opening. Okay, you have to keep test flame here. Okay, this is the setup of the Penske Martin flash point apparatus. See, this is the actual Penske Martin instrument. This is the actual Penske Martin instrument. By using this regulator, we can regulate the temperature inside this. Okay, this is the stirrer bar. By using this, we can rotate the inside this stirrer will be there. It will rotate and the uniform heating will be takes place for the lubricant oil. The procedure. See, clean the oil cup thoroughly and fill the oil cup with the sample oil to be tested up to the mark. First, you have to clean the oil cup and then you have to fill the oil inside the cup up to the mark. Insert the thermometer into the oil cup. Then you have to insert the thermometer into the oil cup through a provision. One inlet is there. Through inlet, you have to keep the thermometer, which measures the rise of oil temperature. By using thermometer, we can measure the temperature, how much it is increasing. Using the energy regulator, control the power supply given to the heater and rate of heating. Using the energy regulator, we can control the power supply. By that, heater and rate of the heating we can control. The oil is heated slowly when the temperature of oil rises. The oil is heated slowly when temperature of the oil rises. Okay, by using these heaters, we are providing heat into this oil bath. Okay, the temperature of the oil will be slowly increases or slowly rises. It is checked for the flash point for every 1 degree centigrade rise in the temperature. It is checked for the flash point will be checked for every 1 degree centigrade rise in the temperature. Okay. After the determination of the flash point, the heating shall be further continued. The temperature at which time of flame application which causes burning for a period of at least 5 seconds shall be recorded as the fire point. What happens? The temperature at which time of flame application which causes burning for a period of at least 5 seconds shall be recorded. That is called fire point. Repeat the experiment 2 or 3 times with fresh sample of the same oil. Repeat the experiment 2 or 3 times with the fresh sample of the same oil. Take the average value of the flash and fire points. By using Penske Martin instrument, we can measure the flash and fire point. First we will get the flash point, then after we will get the fire point. See, this is the when we bring the flame to here, we can observe the flash and fire points. Okay, this is the shutter. This is the shutter opening and shutter closing. The next property of the lubricating oil is cloud and pour point. The next property of the lubricant oil is cloud and pour point. See, cloud point. When an oil is cooled slowly, the temperature at which the oil becomes cloudy in appearance is called cloud point. When an oil is cooled slowly, the temperature at which the oil becomes cloudy. The oil becomes cloudy in appearance is called cloud point. When the oil is cooled, in the previous flash and fire point, we have increased the temperature. But here to measure the cloud and pour point, we have to decrease the temperature from the room temperature. From room temperature onwards, we have to decrease the lubricating oil temperature. In the flash and fire point, reverse we have done reversely. Okay, to measure the flash and fire point times, we have to increase the temperature. But to measure the cloud and pour point, we have to decrease these temperatures of the lubricating oil. See the cloud point. When oil is cooled slowly, the temperature at which the oil becomes cloudy, in appearance is called cloud point of that oil. Or the temperature at which the impurities being to separate from the solution and lubricating oil becomes cloudy or hazy in appearance is called cloud point. The temperature at which the impurities being to separate from the solution and lubricating oil becomes cloudy or hazy in appearance is called cloud point. Then the next one is pour point. The temperature at which the oil ceases to flow or pour is called pour point. The temperature at which the oil ceases to flow or pour is called its pour point. The significance of the cloud and pour point. See, most of the petroleum based lubricating oils contain dissolved paraffin wax and aspartic impurities. When the oil is cooled, these impurities undergo solidification, which cause jamming of the machine. So the cloud and pour points indicate the suitability of the lubricants in cold condition. The significance of the cloud point and pour point is the temperature at which the significance of the cloud and pour point is the most of the petroleum based lubricating oils are contain paraffin wax and aspartic impurities. When the oil is cooled, these impurities undergo solidification. Which cause jamming of the machine. So the cloud and pour points indicate the suitability of the lubricants in cold conditions. A good lubricating must have low cloud and pour points. In order to understand the suitability of the lubricants in cold conditions, we make use the cloud point and pour points. In order to understand the suitability of the lubricants in cold conditions. To understand the suitability of the lubricants, we make use of cloud paint and pour paints. So you should know the cloud and pour paints. Usually lubricating oils derived from petroleum contains dissolved paraffin wax and other aesthetic impurities. Usually lubricating oil derived from the petroleum contains dissolved paraffin wax and etc. impurities. These impurities tend to separate out of the oil at lower temperature. These impurities tends to separate out of the oil at low temperature. Further solidification of lubricant normally causes jamming of the machine. Further solidification of the lubricant normally causes jamming of the machine. The cloud point is the temperature at which crystallization of solids in the form of cloud or haze first becomes noticeable. Okay. The cloud point is temperature at which the crystallization of the solid in the form of cloud or hazy first becomes noticeable. When the oil is cooled in a standard apparatus at the standard rate. When the oil is cooled in a standard condition and standard rate. The pour point is the temperature at which the oil just ceases to flow. Okay, the pour point is the temperature at which the oil just ceases to flow when cooled at standard rate in a standard apparatus. The pour point is the temperature at which the oil just ceases to flow when cooled at a standard rate in standard apparatus. It's called pour point. The pour point has a greater significance for a lubricating oils. The pour point has a greater significance for a lubricating oils. It determines the suitability of a lubricant or hydraulic oil for low temperature installation. It determines the suitability of the lubricant or hydraulic oil for the low temperature installation. The important examples are refrigerator plants and aircraft engines, which may required to start and operate at sub-zero temperatures. Important examples of the cloud and pour points are refrigerator plants and aircraft engines, which may be required to start and operate at sub-zero temperatures. The apparatus used for the conducting both these tests. Okay, only one instrument, only one apparatus can be used to measure these cloud and pour point. Okay, the apparatus consists of a flat bottom tube enclosed in a air jacket. This apparatus, this cloud and pour point instrumentation contain a flat test tube. Okay, it contains a flat test tube. In that, it is enclosed in a air jacket. It is surrounded by the air jacket. This tube is placed in a glass jar having suitable freezing mixers and a thermometer. And this test tube in jacket should be inserted in a glass having the suitable freezing mixers. In that suitable freezing mixers you should keep, and you have to insert a thermometer. Different freezing mixers are tried depending upon the type of lubricating oil. Okay, depending upon the lubricating oil, you have to take the different types of freezing mixtures. Examples are mixtures of ice and salt. It is a one type of freezing mixture, and ice and water. This is one type of freezing mixture, and ice and calcium chloride and solid CO2 and acetone are commonly used for the freezing mixtures. By using this freezing mixture, we can cool the lubricating oil. Okay. This is the setup of the cloud and pour point instrumentation. It is a thermometer. Okay, this is the curve. To hold the thermometer, we have to insert a curve, and this is the jacket. This is the air jacket, and this is the gasket. In that gasket, cooling. This is the cooling bar. Okay, this is the disc. This is a test tube. Okay, in the test tube, we have to fill the oil, lubricating oil. The oil is first dried by shaking it with a small amount of anhydrous sodium sulfate. Okay, by using sodium sulfate, we have to dry the test tube. Okay, the oil first dried by shaking. First, the oil should be dried by using this anhydrous sodium sulfate and filtered through a filter papers, and filter the oil with the filter papers. The oil is filled up to the mark inside the flat bottom glass tube, and the cork is fitted with a thermometer dipping inside the oil. The oil is filled up with a lubricating. The oil is filled up to the mark inside the flat bottom glass tube, and the cork is fitted with a thermometer dipping inside the oil. The tube is then kept in freezing mixer. This setup should be kept in the freezing mixer. The temperature of the oil falls on cooling. The temperature of the oil will be decreasing. The tube is taken out of the freezing mixture for every 1 degree centigrade. For every 1 degree centigrade, you take out this test tube from the freezing mixture, and for every 1 degree centigrade fall of temperature of the oil, and then inspect for a movement. For every 1 degree centigrade, we have to observe we are getting cloudy or not. Okay. So this is the setup inside. Okay, these are the flat bottom test tubes. In that we have to take oil. Okay, the samples are placed in a temperature regulated chiller bath. This is a temperature regulated chiller bath. We have to keep the oil, the test tubes with oil. At every 1 degree centigrade decrease in the sample temperature, the test jar is removed. For every 1 degree centigrade, you remove that test oil. Okay, and the bottom of the sample is observed. See, the bottom of the sample is observed. After the first wax crystal forms, okay, after sometimes cooling, the wax present in the oil will be get solidification. So that some cloudy will be observed. Okay, the just jar is removed and held horizontally for every 3 degrees centigrade. It's the sample temperature until the no surface movement is observed. If you decrease the temperature at some temperature, decreasing some temperature, we will get the crystallization solidification. So the oil can be look like that cloudy or hazy type. That is called, the temperature is called cloud point. Okay, if you temperature decreasing continuously, then what happens? For every 3 degrees centigrade, you have to observe this pore point. See, the temperature at which wax crystals first form is called cloud point. First form is called cloud point. The temperature at which wax crystals form, that is called cloud point. The temperature 3 degrees centigrade above the temperature at which the sample remains stationary is the pore point. Okay, after the increasing 3 degrees centigrade continuously, the above the from temperature at which the sample remains stationary is called pore point. See, a pore point is measured at the center of the sample. The pore point is measured at the center of the sample. The temperature at which cloudiness or haziness is first noticed represents the cloud point. The temperature at which the cloudiness or haziness first observed, that temperature is called cloud point. As the cooling is further continued, at a particular temperature, the oil just ceases to flow or pour as observed from the tilting the test jar. Tilting the test jar, what happens? As the cooling is further continued after cloud point, at a particular temperature, the oil just ceases to flow, or pour as observed from the tilting the test jar. If the tilt the test jar, the flow will be ceased for at some temperature, that is called pour point. This particular temperature at which the oil does not flow in the test jar for 5 seconds and tilting the in horizontal position. At this particular temperature at which the oil does not flow in the test jar for 5 seconds and tilting in horizontal position is reported as the pour point. The cloud point is useful for estimating the temperature at which filter screens in the fuel intake system of diesel engines might become clogged because of separation of wax. Cloud point is useful for the estimating the temperature at which filter screens in the fuel intake systems of engine might become clogged because of separation of wax. The pour point values of petroleum and non-petroleum lubricants are necessary. Pour point values of petroleum and non-petroleum lubricants are necessary when functioning under sub-freezing conditions. A good lubricating oil should possess low cloud and pour points. This is the setup of the cloud and pour point. This is the flat bottom test tube. It is the air jacket. This is the jar. We have to fill the oil, and this is a cork dish, and we have to fill with the ice cooling mixes like ice and salt. The next property of the lubricant oil is oiliness. It is one of the most important property of the lubricants which possessed by oils. It is one of the most important property of the lubricant which possessed by oils. It is a property by virtue of which an oil remains adhered to the lubricating surface. It is a property by virtue of an oil remains adhered to the lubricating surface is called oiliness. The oiliness of lubricants. It is the property of the lubricant to stick on the surface under the conditions of high speed and heavy load. It is the property of the lubricant to stick on the surface under the conditions of high speed and heavy load. Oiliness is directly related to the specific gravity of oil. Oiliness is directly related to the specific gravity of the oil. Lower the specific gravity or density. Lower the specific gravity or density, higher is the oiliness. Higher is the oiliness. The oils are generally either saturated and unsaturated fatty acids. The oils are generally made up of with saturated and unsaturated fatty acids. The vegetable or animal oils are with higher oiliness compared to the mineral oils. The vegetable or animal oils are with it contain higher oiliness compared to the mineral oils. Oiliness is an oil enhancement property provided through the use of chemical additives known as anti-wear agents. Oiliness is an oil enhancement property provided through the use of some chemicals. It's called anti-wear agents. These are generally used in extreme pressure lubrication. These are generally used in the extreme pressure lubrication. Understanding these properties and selecting lubricants based on the specific requirements of an application is crucial for ensuring optimal performance of and long life of machinery. Understanding these properties like flash and fire point, viscosity, cloud and pour points, and oiliness. These properties and selecting the lubricant based on the specific requirements, of an applications is crucial. For ensuring optimal performance and long life of machinery. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.